In this video I want to talk about some applications of Octave, especially curve fitting, differential equations and Fourier transforms. Let's start with curve fitting. Let's say we have downloaded some data, for example the time series of the current COVID-19 cases in Germany, which I can download from this website, and then I want to plot this data and fit a curve. To do so, I can read the data into Octave with the command csv read. So let's try it out. I load the data into the variable y with the command csv read. Now the file name COVID-19 active cases.csv. Then I need the x variable, which of course have to be the same length as the y variable if I want to plot it. So I define it as the range from 1 to the length of y. Now I do a scatter plot, which basically is like a normal plot, but instead of connecting the points with lines, it just draws circles. So it is very useful for visualizing data instead of mathematical functions. Scatter x, y, and let's make it black. Okay. Now I use a pause command to stop Octave from closing the window too fast, and if I execute this now, I see the plot with the COVID-19 cases over time. You see it's not very specific. There is some error, one could say, so I want to fit a function to these data. I could do this by using spline interpolation. So what is spline interpolation? Basically, if I have some data points like the red dots in this picture, I want to fit a curve such that it follows the data points nicely. For example, the green one is not very accurate enough, but the blue one here would fit a bit better. I can do this by using spline interpolation. So I define the breakpoints for this spline inside the variable breaks from 0 to length of y, and how many breakpoints do I want to have? Let's say 171, and then I define the spline interpolation as a variable sp. So I do spline fit. The command spline fit does spline interpolation. I define the x, the y variables, and of course the breakpoints. The more breakpoints I have, the more it will do overfitting, and the less breakpoints I have, it will lead to underfitting, so one has to do a bit of trial and error to see what looks good. So now I want to plot this function. So sp is the fitted spline interpolation now, and to plot this I can make linspace from let's do it like this, and y is I have to evaluate the spline with the command p-eval. It's a bit weird command, but this means spline evaluate, and then sp, the interval where I want to evaluate is xx. So now I can plot this. Of course, I do not have to forget that I have to use the command hold on after scatter, because otherwise it will delete the first plot. And if I look at this now, I see that the fitted line is a bit too sensitive, so I have to use have used too much breakpoints. I need less breakpoints because this is a bit of overfitting. Yeah, so I could try different number of breakpoints, and let's make a for loop for n is equal to 171, 51, and let's say just use a few, just 5. And then I will plot this. And instead of 171 breakpoints, I just use n breakpoints. So we iterate over the entries in this array. So first I use 171 breakpoints, then 51, then 5. And so I have 3 plots now, 3 curves to fit, and we will see how it looks. So yeah, now we see the yellow line is it does underfitting, so this is 5 is not enough breakpoints. Blue ones with 171 we had before, this was overfitting, so the orange line looks good. This looks like an accurate approximation, so I think we can just delete the for loop or just comment it out, and then use n equals to 51 breakpoints, and if I now plot this, I have a nice fitted curve. So that's how you could do a curve fitting with Octave.